Hello everyone, July 14th. Let's do this. Create binary tree from descriptions. You're given 2D integer descriptions where parent-child is left indicates the parent of a child and a binary tree of unique values. Left is 1 is a left child, left is 0 is a right child. Construct the binary tree described and return the root. Okay, so 20, 15, 1, which means we have 20, 15. 20 is a root. 15 is, no, 20 is a parent, 15 is a left tree, And now we have 20 again, then we do a right tree. Now we have 50, then we go to the left. Yeah, I think I can just use a map. Right, can we do that? Can we do a map? I think we can. And we'll have to do this. Okay, so we need a map of integer and tree node. Node map. Okay, and for int d of descriptions, right? If d0 is the parent, we can actually do the node map first. So we can say node map dot add, no, set, wait, what's it called? Put, if absent, d0 new tree node of d0, right? And I would say node map dot put if absent. Node map dot put if absent d1 new tree node d1. Right? We get both, and then we say if d2 is equal to 1 is the left, right? Then we say node map dot get d0 dot left equal to node map dot get d1. Else we can copy this line and call it right. Oh, we need to return a root. Who is the root? Damn. Good question. Who is a root? Yeah, this can definitely construct a tree, but we don't know the root. So as we go through, like we say 20 is current root. 20 and then 50. But how do you know 50 is a root? Good question. How do we know which one is the root after we finish constructing the tree? Well, we can say, okay, we can use integrity to decide who is the root, but I wonder if there is another way to decide who is the root. So I'm making connections, right? I'm making connections. So every time I make a connection, I can say, can I say the current root, right? I say, okay, it's 20. And then the next time we see, if the child is 20, so we say, okay, 50 must be the current root. Maybe. As we go through, we set up a current root. And every time if there's a parent to the current root, we set that as the current root. Because eventually everyone will get visited. And the root will be the one that does not have, okay, so that might work. Okay, let's try this. So we can say current root is, I don't even know what this one is, right? It doesn't matter. So as we go through, so we set up the tree and then we say if so if current root is smaller than 0, yeah, we set a d0 as a root. If, yes, so we can say if current root is smaller than 0, wait, what's the value? Parent child, I can actually do 0. I can actually do 0. Okay, let's do 0. Right, let's do 0. So we say if this is equal to 0, then we say current root shall equal to d0. That's the parent. Else, if current root is equal to d1, it's equal to this, or current root is equal to d1, becomes the, yes, so either if we are starting or the current root. We can actually do this. We can do descriptions 0, 1, right? That's the current root we set to this, and then we only need to do this. We need to only check for 1. Yeah, basically means if the current child, if the child turns out to be the current root, then we need to reset the current root. So we go through this, and eventually we'll return node_map.get current root. All right, let's take a look. See if this one works. I think it probably work. So let's do the summary here. 2196. Construct the tree with the help of a hash map, which maps the value of the tree node to the actual tree node. We also use a temporary value to keep track of the value, the root value, right? The root value. Call it on, and let's submit this. Hopefully we have considered all the cases. Oh, I've done this before. Huh. Oh, I got a wrong answer. That is bad. Oh, it's interesting. I'm missing 1, 2, 3, 4. 1, 2. I'm missing stuff. Connecting. You're not connecting them, right? How? Wow, it's worse performance than last time. Last time I did it in one shot. How am I not connecting them? 74, 13, 39 cents. So I have this, but I'm missing part of it. Huh. 38, 82, 82, 85, and 85 to 74. How is that possible? Interesting. Hold on, I'll be back. Tuve más bien. Jimbo. Alright, back with it. Trying to figure out where we did wrong. Okay, 3970, we good. And yeah, we can actually plug a link. So we have, oh my, how did I send my stuff? Oh, here. No, monitor 3. There we go. Okay, so we have 39, 70, and now we have 13, 39, and we have 85, 74. We should have 74 and 13. And we shall have 38, 38, and 82, and 82, and this. How in the world this did not work out? Yeah, D2 is equal to 1, so everybody is going to the left. Oh, I think the current node is wrong. Yep, I think the issues with the current node. We did not. I think we only traced it back to 74. Right, we traced back to 74. Because we hit 74. So initially we say 39, and then we go to 13, and then we did not set 85. Then we set 74. Oh, okay. So we have to find a different way to do the current root. How can we do that? So we are at something, and then we say this is the root parent, so we pick the parent. And then somewhere else we pick another parent. Okay? So now we have parent. What if we use a set? Right? What if we use a set? All the parents put in the set, and then if someone becomes a child, we simply remove it from the set. So I'll say not this. Say set integer parents. Okay, then we say if parents dot contains d1, parents dot remove d1, because d1 is a child, and the parents dot add d0, and at the end, how to get the value? Java get value from set. Can I iterate through set? Yeah, I can. I think I can. I can do for int r of parents return node map dot get r. No. Yeah. But it will not be called. Set to identify the root. All right, try this one. My goodness, this one's even more wrong. Dude, how did I find the root? First is not right. Oh my goodness, it's wrong on so many levels. Do we have a lot of things in this? I don't believe this. This is ridiculous. Let me think again. I thought parents only have one, because I always remove the... So we only get 80 and 19, because I think 80 is... Okay, let's see what happens. So as we go, we put 20, right? So 20, what is the thing look like? Yeah, so we put 20 in it, right? Because we put D0 in it, right? 20 is in it, and then 20 is in it, and then we say it contain 20, yes, I remove 20, so 50 is in it, right? 50 is in it, and then 50 is in it, and then 80 is in it. That's why 80 is in it. See, that is the issue, because we already have 80 here, so we know 80 is not a parent. I mean, okay, I don't want to do it, but I guess we have to do it. We're gonna use the map integer and integer in degrees. Yeah, I don't want to use it initially, but now we're using a set, we might as well just do in degrees. That's fine. So basically we're gonna do in degrees dot, oh my god, yes, put if absent d0 will be we're just counting, right? We just counting, so I can just say put d0 and in degrees dot get or default d0 get or default. 0 plus 1. Actually, that's not even it. This should be 1, because that's what we have in degrees, right? That's the in degree. So everyone we have the in degree. But it's a tree, it's a binary tree, so you want to have one in degree. So basically we find whoever does not have in degree, right? So each one will get in degree. So it's gonna be a true or false. Right? True or false? Yes, yes, yes. Is... Wait, how big is the whole thing? 10 to the 5th? I might as well just try it, right? 10 to the 5th is not that big. Do we even want to use hash map? Can we do a, tree node map, new tree node, I don't know, 10 to the 5th. Right, the value. 10 to the 5th. 10 to the 5th. It's 100,000. Yeah. 100,000. I feel like that's a bit of wasting. So this is not going to be this. This is just going to be a true or false. This is going to be a Boolean value, right? It's not going to be in degrees. Is child. Right? And then we say is child dot put d1 true for sure, right? And if is child dot contains key d0, if it does not contain key, just like this. And we just need to go through the whole thing to find whoever is, this is true. And then we say, we just go through this one more time. So we set this child, so we go through this one more time. So for int d, oh my god, I'll do this one more time. Of descriptions, if is child dot get our default d0 false, return node map dot get d0. We use another hash map to keep track of the value, the root value. Okay, this hopefully is right. All right, submit. To hash map. Definitely not. Probably not a right solution or the ideal solution. BFS. Just using sets. Oh. Then what is this? I don't know what this is. Mapping. I think this is our method. That is smart. You get a children, so the one that's not in the children is the... Okay. Alright, that's it for today. I will see you guys tomorrow.